Nomenclature. So we need to learn how to name these guys. Naming. You're not going to OChem. Well, that's okay, because this isn't OChem. This isn't organic nomenclature. This is coordination compound nomenclature. So we first have to learn how to name the complex ion. So we name the ligands. Neutral ligands are named the same as molecules with a couple of exceptions. H2O is called aqua, NH3 is called amine, and CO, carbon monoxide, is called carbonyl. So examples over here, this guy, that is ethylene diamine. And so when we name, if that's the ligand, we use its regular name. But those exceptions, if H2O is the ligand, we call it aqua. Then you name the anionic ligands. And here we take the name of the ion, and then we modify the ending. So basically, we're throwing an O on here, but we have to get rid of some stuff sometimes. So if it's "ide," like chloride, it becomes chloro. Fluoride would be fluoro, etc. If the anion has an "ate" ending, like sulfate, then it's sulfato. So you take off the...
Isn't it Spanish?
No, it's not Spanish. It's chemistry language. If it's "ite," we change the E to O, and it's sulfito, or sulfito probably. Sulfito. Sounds like a dog. Anyway, there's a table that I'll show you later that lists the names of some of the common ligands. So you have to identify the names of the ligands, and then you list the names of the ligands first in alphabetical order, and then you have to tell how many there are. So if we've got amine and chloro and nitrito, they go in alphabetical order. Amine, chloro, nitrito. We're going to use a prefix to tell how many there are if there's more than one. Because this is not like an ionic compound where you're going to figure it out from charges. There could be 3 ammonia molecules, there could be 4, so we have to include that. So we're going to use those regular prefixes, di, tri, tetra, penta, or hexa. So trichloro means there's 3 chloride ion ligands. Tetraamine indicates 4 NH3 ligands. If the name of the ligand has a numerical prefix in it, then we have to use bis, tris, or tetrakis to indicate the number. So ethylene diamine has the prefix di in it. And so then we use the second level numerical prefixes so it doesn't get all mixed up. And so we're going to put tris for 3 and use parentheses, trisethylene diamine, to indicate 3 of those guys.
Just triethylene diamine is completely different.
Yeah, triethylene diamine would be something else. The prefixes do not affect the alphabetical order. You don't include the prefixes when you alphabetize those. So you get all the ligands and how many there are, and you put them in alphabetical order, and then you look at the name of the metal. If the complex ion is a cation, use the name of the metal followed by the oxidation state with the Roman numeral. These are, after all, transition metals, and we use Roman numerals with them for the most part. So, CO3 plus, cobalt 3, etc. The complex ion can be an anion. If you've got more anionic ligands than there's charge on your cation, you can have a negative complex ion. And so then what we do is we take the ending of the element name, cobalt becomes cobaltate, but you still have to indicate the charge. Platinum becomes platinate, and some of them revert to their Latin names. So we've got cuprate instead of copperate, because that would sound dumb, wouldn't it? Copperate. So we've got all the pieces now. Well, most of the pieces. We've got all the pieces for the complex ion. So for the entire name of the complex ion, you list them all, listing the ligands in alphabetical order with prefixes to tell how many, and then the metal name. And so PT, NH32Cl4, 2-. This is an anion, and so it's got platinate at the end. We can tell from the chloride, number of chlorides and their charges and the overall charge that it's platinum 2. And so this is diamine tetrachloroplatinate 2. Believe me, the computer loves this because it wants to break onto the next line and it just doesn't know what to do. And this guy would be hexaamine cobalt 3. Any questions? These are the promise tables. Names and formulas of common ligands. Here's cyanide. That "ide" ending changes to O, so cyano. Oxalate is oxalato. Sounds like gelato or something. And here are the names for the ions. Silver and tin revert to their Latin names, as does gold and iron and lead. Orate. Yeah. Yes.
So this test is going to be take home, so we don't necessarily need to memorize all this, but will we need to have it memorized for the ACS test?
There will be some of this on the ACS exam. And so hopefully by doing the homework and doing the take-home test, you'll become familiar with it. Once you work with it a little bit, a lot of it is just an extension of things we've done before. So if you're wanting to get a high A on the ACS exam, then you need to devote some time to memorizing this stuff. If you're just trying to pass, I would spend my time on other areas.
Well, now ACS come up. Couple questions.
Mm-hmm.
How much is that worth of a room? A lot, right? 5%?
I'll answer that question later. Do you have any questions about this?
But, does it still have that same?
So naming coordination compounds. So that's not what I meant to do. No, it is. Okay, never mind. When we're writing the formula, we talked about naming. This is writing the formula. First, you write the symbol of the metal, and then you write neutral molecule formulas, and then anions. And if there's more than one neutral molecule or more than one anion acting as a ligand, list them in alphabetical order based on the chemical symbol. Not their name, but the chemical symbol. Examples. Name the following compounds. Fun. So we need to name the ligands first. Steve and George. This.
We have amine. We have 5 of them.
Oh, I'm writing with white. That doesn't work. This is carbonyl. And amine with 2 M's.
Penta, right?
Right, and so we've got one carbonyl, and just like chemists don't like to write the number 1, we avoid using the prefix for 1, mono, so we're going to leave that out. You have a question?
The prefix of like the tri, penta, and all that, does that affect the alphabet?
No, it doesn't. Numerical prefixes are not considered when alphabetizing. So amine, there's 5 of them, and so we've got pentaamine. So between amine and carbonyl, amine goes first. So this is, oops, I forgot the prefix. Pentaamine. Pentaamine carbonyl. And then what's the name of the metal ion?
Manganese.
Manganese. We don't have to change the ending because the complex ion is a cation. What's the charge on that? It's going to be +2 because the carbonyl and the amine are both molecules. Sulfate has a -2 charge, and so the manganese must have a +2 charge. Manganese 2, and then the counter ion is sulfate. Pentaamine carbonyl manganese 2 sulfate.
Nice.
Right? And the 3A people are complaining about iron 3 oxide.
I would too.
Okay, what about this guy?
That's backwards.
So here the complex ion is the anion, right?
Yeah.
We always name the cation first and then the anion. So it's sodium. But then the name of this guy, the ligand is, it'll be tetrachloro, right? It's going to have an ending change to 8. So we've got sodium, tetrachloro, platinate. And what's the charge on the platinum ion? Well, let's think about this. We've got 4 chlorines, right? So that's a total of -4. And we got 2 sodiums, so that's a total of +2. It must be +2. Platinate 2. Sodium, tetrachloroplatinate 2. We're not going to say disodium because the ionic charges tell us how many of each. We have to use these numerical prefixes in here because these are not really affecting the charges. There's no other way to figure them out. Any questions?